All right, going to take you a quick overview of solving radical equations. So what we're going to do, we're going to continue to isolate the radical term, and then we're going to square or cube or do it to the fourth power for both sides so that we can move that x value out of the radical and then be able to solve for x. So just remember when we're squaring something, it's basically saying, for number one, for instance, if I'm going to square the square root of 7x minus 18 and square 5, squaring 5 is just 5 times 5, so 25, we know that. But when I'm squaring the square root of 7x minus 18, it's like I'm saying 7x minus 18 times 7x minus 18, and then that's part of the square root. So one of the things that we've talked about is that like the way I can get something out of the square root is if I have a pair. And so squaring this is literally making a pair. So it's almost like I'm doing this times itself so that it can move outside of there. You can also think of it as the fractional roots of that. The square root would say 7x minus 18 to the 1/2 power. And our law of exponents says if we raise the 1/2 power to the second power, I'd multiply those together and it just cancel each other out and go to the first power. Either way, however you think of it, that's going to end up being 7x minus 18 equals 25. And so then I just do my solving steps for the one variable equation there. So add 18 to both sides gives me 43. So 7x is going to equal 43. And my last step would be to divide both sides by 43. So I've got that x equals 43 over 7. And then we're going to check our answers just to make sure that it works out like it's supposed to. So if I put in square root of 7 times 43 over 7 minus 18, then what I should end up with is a 5. So when I multiply that, 7 times 43 over 7 would give me just 43. And then if I subtract 18 from that, that's going to get me back down to 25. And the square root of 25 does equal 5. So that is just a check to make sure that my answer is correct. And so I'm only going to box it and put it in as a solution after I've checked it to make sure that it works out like it's supposed to. Okay, as we go on from there, this adds an extra step of needing to take away this 1 from the left side before I square both sides. So I'll just subtract 1. Those cancel out. Gets me a 2 on this side, which is equal to the square root of 3x minus 8. And when I square both of those, it gives me 3x minus 8 equals 2 squared, which is 4. Solve that by adding 8 to both sides to get 12. So 3x is equal to 12. And then we'll just divide by 3 to get x equals 4. Once again, I'm going to check that, and you're more than welcome to just put that in the calculator, but it's a quick check, so we will work it out here. So I have the square root of 3 times 4 minus 8 plus 1, and that should equal to 3. That gives me 12 minus 8 to get the square root of 4, which is 2. So the square root of 4 is 2, plus 1 does equal 3. That checks out. So then my answer is going to be here with x equals 4. And now we've got one with a cubed root. So same thing, I need to isolate that radical. I'll do that first by adding 24 to both sides. Cancel that out. And then I have 8, the cubed root of x equals 24. And if I divide that by 8, I end up getting the cubed root of x equals 24 divided by 8, which would be 3. And so now instead of squaring it, I need a group of 3 to get that out, so I'd have to cube it. So I'm going to take 3 and raise it to the third power to get x equals 27. And when I check that, just kind of a reversal of what we've been doing. So 8 times the cubed root of 27, which is going to be 3, minus 24, I should just end up with nothing. So the cubed root of 27 is 3. And 8 times 3 I know is 24, so it's looking good for us. So if that's 24, we subtract it, and that's going to equal to 0. So I will always make sure on this as you're going through and checking it. That's why I go back and box my x equals afterwards. So I make sure that I just don't get my solution mixed up of x equals 27, and I can go back to that. But I also don't want to go ahead and write it in case I end up with a no solution on there. Looking at a couple more, we got 7 plus 4x equals 3. So I'll start out by isolating that radical. You get 4 times the square root of x equals negative 4. Then the square root of x, because I'll divide by 4 on both sides. So the square root of x is just going to equal a negative 1. And then I'll square both sides. What that gives me is negative 1 times negative 1, which would get me x equaling to a positive 1. And so on this step right here, this is one of the ones where you want to be really aware when I have a negative over here that gets squared and it changes the sign as a result. When that sign changes, that's when we want to be really aware that there's the potential for something iffy to be going on and things to not work out. So when I plug that in, 7 plus 4 times the square root of 1, which would just be 1, that ends up giving me 7 plus 4, and that's not equal to 3. If it was minus 4, that'd be equal to 3, but we don't have a way to get a real solution that is equal to a negative 1 there to change the sign of that. So because of that, I will say that is no solution. So you could put NS or a 0 with a diagonal line through it. Any of those things work for it. Okay, let's look at, I guess we'll look at 2 more because this one I think is going to end up with a 1 on the inside as well. So starting out, subtract 6 to get me 1 equaling the 4th root of 2x plus 3. So the main thing on this one that they're wanting you to recognize is that because it's the 4th root, that means I need a group of 4. So I have to raise it to the 4th power. And 1, though, if I raise 1 to the 4th power, it's still going to give me just 1. But that is going to bring out this 2x plus 3. So I'll subtract 3 from both sides. Give me a negative 2. So then I've got 2x equals negative 2. And I'll divide by that to get x equals -1. So an important thing to notice here, even though I got a -1, which we saw -1 over here, changing the sign, the sign change comes because of the algebraic steps we do within this. So when I did it to the fourth power here, that doesn't cause the sign change, so we should be good, but we're going to check it anyways. So the fourth root of 2 times -1 plus 3, all that plus 6 should get me 7. And so what happens here is 2 times -1 just gets me -2, to leave me with the fourth root of 1, which would still be 1. And so 1 plus 6 is going to give me 7. Works out. So my x value will be just -1. And the last one on here, you're taking and putting every single step we've got together. So these are all just algebraic steps that you're doing. The only new concept of this is taking and squaring both sides or doing it to the fourth root. Doing that type of thing as you're solving this. So when I do this, I'm going to add 2 to both sides. Gives me 25. And so 5 times the square root of 7x plus 4. Now before I square it, I've got to get rid of this 5. If I don't, I'd square the 5 as well. And squaring 25 gets me a lot larger number that I'm just going to divide by 25 anyways. So dividing by 5 here just makes the work a lot easier for us. So that gives me square root of 7x plus 4 equals 5. And then I'm going to square it to give me 7x plus 4 equaling 25. Okay. Then I have 4 I've got to deal with. So positive 4 minus 4 and 25 minus 4 to get 21. And you can kind of see how they develop this problem of, I want x to equal, like I want to multiply 7 times 3. And so then they got 21 from that and said, well, if I add 4 to that, it'll get 25. And I can do the square root of that real easily, and kind of worked it backwards to just give you a bigger, longer, drawn-out problem that ends up with x equaling just 3. So again, I've got x equals 3. We're going to plug it in. And again, I will say you can feel free to plug it into the calculator. It is just going and reversing the steps that you've done if you've done all your steps right. So I get 21 here plus 4. And then we're going to do the square root of that times 5 and minus 2. So 25, I take the square root of it, it's 5. I get 5 times 5 minus 2 should equal 23. I know 5 times 5 is 25 minus 2 does give me 23. So I'll go back, find my x equals, box it, and that is my answer because it checks out. So x equals 3. And then we'll look afterwards at what to do if you've got a radical on both sides of the equation.